Linear Algebra, a review lecture on the determinant. So the determinant is a special number associated with any square matrix. First of all, we're going to deal with how it's calculated, then we'll talk about the intuition and why it's important. So how is it calculated? It depends on the matrix, how big it is. If you have a 2 by 2 square matrix, then it's calculated as AD minus BC. For a 3 by 3 matrix, it's calculated as A times the determinant of this matrix minus B times the determinant of this matrix, DFGI, plus C times the determinant of this matrix, DEGH. Now what's going on here? For each one, A, we take out this row and this column. For B, we take out this column and this row. For C, we take out this column and this row, leaving the final matrix. When we do these, this is quite simple using the above form. So the determinant of this matrix is EI minus FH, EI minus FH, and then just multiplying out the bracket. Same here, DI minus FG, multiplying out the bracket, and then DH minus EG. So that's the calculation of a matrix. And what's the intuition behind the determinant? In some sense, it's easiest just to think of the determinant as some fancy mathematical equation which somebody randomly came up with. But what makes it interesting, unlike, say, most random equations you might come up with relating to the elements of a matrix, the determinant has several important and useful properties. Let's bring some intuition to this. The determinant's geometric meaning is related to its measure as a scale factor. What does this mean? It's a scale factor relating to the area, say. So the determinant of a 2 by 2 matrix was 2, then the matrix has an area scale factor of 2. So you can imagine a matrix plotting out the points on a graph, and this determinant is increasing or decreasing the area in between those points. It's not too important that you have that intuitive understanding. The main thing to realize is that it's a special number with this formula we have here, and it turns out a whole bunch of interesting stuff comes from it. One interesting property, perhaps the most interesting property for us right now, is that a matrix, a square matrix, because you can only take the determinant of a square matrix, a matrix is invertible if and only if its determinant is non-zero. If its determinant is 0, then it's not invertible. If its determinant is non-zero, then it is invertible, which is a very important property.